I want you to picture a moment. I think every single one of us has had this moment.
Okay.
You're standing in your bathroom. You've just used the very last drop of a really nice beauty product. Maybe it's this heavy, expensive feeling glass jar of moisturizer. Or maybe now it's empty. And you're hovering over the recycling bin, holding this thing, and you just freeze.
A moment of hesitation.
Exactly. It's just total confusion. You think, does this go in the blue bin? Is just trash?
You have to wash it out first. What about the lid? The lid feels different.
Yes. And let's be honest, half the time you just toss it in and kind of hope for the best.
That is actually a documented phenomenon. They call it wish cycling. And it comes from a good place. You want to do the right thing.
Of course.
But it's a nightmare for waste management facilities. But honestly, your confusion is completely justified because that little jar represents this massive, invisible conflict in the world of manufacturing.
Right. And that is exactly what we are unpacking today. We're doing a deep dive into the surprisingly complex, science-heavy world of sustainable makeup packaging.
It is surprisingly complex.
We've pulled our insights from a really comprehensive guide by Ingredientsage and some serious industry experts. And let me tell you, this is not just about swapping plastic for cardboard.
Not at all. It is such a high-stakes balancing act. I mean, think about what a cosmetic package actually has to do. It isn't just a bucket.
No.
It has to protect a very delicate chemical formula oils, water, active ingredients from light, from air, from bacteria. It has to survive being shipped across the ocean in a hot container. And for the consumer, it has to feel, well, luxurious.
And that's the core tension, isn't it?
Yeah.
We want to save the planet, but we also want our fancy face cream to feel fancy. We associate weight and complexity with value.
Precisely. The central conflict we're looking at today is how the industry is trying to solve this huge global waste problem without compromising the product's integrity or the consumer's experience. It requires a total rethink.
A rethink of how products are designed, not just what they're made of.
Exactly.
So let's open up the toolkit. When we talk about fixing packaging, the first thing everyone shouts is, recycle! But the source material suggests it is way more nuanced. So let's talk about that first line of defense, PCR.
Right, PCR, which stands for post-consumer recycled plastics.
Okay, so that's basically using plastic that has already lived a life as, I don't know, a water bottle or a yogurt cup.
That's the one. The idea is to keep existing materials in the loop so we aren't drilling for new oil to make virgin plastic. And it sounds like the perfect solution on paper.
It does.
And it is a huge part of the strategy, but the source highlights some really gritty technical challenges here that most of us never think about.
Like what? I mean, if it's plastic, can't we just melt it down and make a new lipstick tube? Why is that so complicated?
You can, technically, but think about the aesthetics, the chemistry. If you're a luxury brand, you want a pristine, bright white bottle or a crystal clear tube.
To show off the product inside.
Exactly. But recycled plastic, it comes from a messy mix of sources, so it often has this kind of grayish or yellowish tint to it.
Because it's a soup of everything we threw away.
Correct. They sometimes call it the gray goo problem. Plus, it can have little specks of contamination, bits of old labels, glues, other polymers that just didn't get filtered out.
And for a $50 lotion, a little black speck on a white bottle is a defect.
It's a deal breaker. So that's the color matching challenge. And then there's quality variability. Plastic isn't like glass. It's made of polymer chains. Every time you heat it up to recycle it, those chains get shorter. The material physically degrades.
So you can't just cycle it forever.
No. So to make this all work, the industry is having to pivot toward a totally different design philosophy. Monomaterials.
Monomaterials, that sounds like exactly what it is, using just one material.
Yes. This is the gold standard for recyclability. Historically, a lot of beauty packaging was a Frankenstein's monster of materials. You might have a peat bottle with a peat keycap, a PVC label, maybe some foil stamping for the logo.
And I'm guessing for a recycling center, that is a nightmare.
It's basically impossible to process economically. These plastics, they all have different melt flow indices. They melt at different temperatures.
Okay.
So if you throw a PVC label into a batch of PT, the PVC just burns and chars before the PE even melts. It ruins the entire batch.
And the machine just spits it out. Or worse, it just contaminates all the output.
Exactly. So the solution is designing the whole package, bottle, cap, everything out of a single resin type, like HDPE or PET. If you do that, the recycling rate skyrockets. It can go straight into the grinder.
Okay, so simplification is key.
Yeah.
But let's talk about the material that I think most of us assume is the good guy.
Glass.
Glass.
Yeah.
I feel like whenever I buy something in glass, I kind of pat myself on the back. It feels eco-friendly. It's infinitely recyclable. Is glass the winner here?
Glass has a fantastic reputation, and, chemically, it deserves it. It's inert, so it doesn't react with the product.
Right.
And, as you said, you can recycle it 1,000,000 times without losing quality. But, and this is a big but, we have to talk about physics. Weight. Glass is heavy. When you look at the carbon footprint of shipping, glass is a major offender. You're burning a lot of fuel to move heavy glass jars around the world.
And I assume making the glass isn't exactly energy-free either.
Far from it. Glass kilns operate at incredibly high temperatures, around 1,500 degrees Celsius. That's extremely energy intensive, so if you're just looking at carbon emissions, glass can sometimes be worse than plastic.
Wow. That's a tough pill to swallow. So it's a trade-off. You get recyclability, but you pay for it in carbon emissions.
Unless you innovate. The source points to recycled content glass, or RCG. If you use glass that's already recycled, they call it cullet, you lower the melting temperatures significantly.
Oh, interesting.
That reduces the energy needed, and some brands are pairing this with aluminum closures.
Why aluminum? I usually think of soda cans, not luxury creams.
Aluminum is fascinating. Keeps that premium weight and that cold touch that people associate with luxury. It feels expensive, but aluminum is infinitely recyclable, just like glass, only it's much lighter and more efficient to reprocess. It lets you cut out virgin plastic, but keep that fancy feel.
That is smart. Now, I have to ask about the buzzword of the decade, bioplastics.
The plant-based stuff.
Yeah, plastic from corn or sugarcane. Is this the silver bullet?
It's a fascinating technology, but silver bullet might be a bit too strong.
Right.
We're talking about materials like PLA polylactic acid or PHA. They come from renewable sources, which is great.
Meaning we're not drilling for oil to make them.
Right. But I sense, there's a however coming.
The source seemed pretty cautious about these.
The however is the end of life. There's this massive misconception that plant-based means you can just throw it in your garden compost and it'll disappear like an apple core.
And that's not true.
Not for most of them, no. Most bioplastics require industrial composting facilities. We're talking high, sustained heat, specific humidity, forced aeration.
Things most people do not have in their backyard. And most cities don't offer that.
Exactly. And here's the kicker. If you throw a PLA bottle into your normal plastic recycling bin because it looks like plastic, it acts like a contaminant.
Oh, no.
Chemically, it's not PET. It can contaminate the whole stream and ruin the recycled batch, just like that PVC label we talked about earlier.
So if the right infrastructure isn't there, a bioplastic bottle might actually be worse than a standard plastic one.
In the current system, yes. It often just ends up in a landfill anyway, where it doesn't degrade well because landfills lack oxygen. So promising, but the infrastructure has to catch up.
It really emphasizes that you can't just look at the material in isolation. You have to look at the whole system.
Which brings us to design. There's a concept in the source called design for disassembly.
This was the part that really made me think about the pumps on my lotion bottles. I never realized how complex a pump is.
It's a marvel of engineering, but a disaster for recycling. A standard lotion pump, it looks like plastic, but inside there's usually a tiny metal spring,
Right.
maybe a glass ball, and several different types of plastic all working together.
And because they're all fused or snapped together.
You can't separate them. That little metal spring effectively makes the whole pump non-recyclable. It gets sorted out as trash.
So design for disassembly means making sure you can actually take it apart.
Or designing it so you don't have to. Strategies include components that easily snap apart, or even better, monomaterial pumps. There are new designs that use a plastic spring made of the same material as the housing.
Oh, clever. So the whole thing can just go in the grinder.
Exactly. It's about deciding the fate of the product on the drawing board long before it ever hits a shelf.
And speaking of keeping things off the shelf, let's talk about the refill revolution. I'm seeing this everywhere now.
You buy one nice jar, and then you buy little pods or pouches to refill it.
Yes. This is where we see the circular economy really trying to take hold.
It's logical, right? Why pay for a heavy glass jar every month?
You just need the cream inside.
But the source mentions this isn't as simple as it sounds.
No, it's a huge logistical hurdle. It requires a massive shift in consumer behavior. You, the listener, you have to be willing to clean the container properly. You have to remember to buy the refill. And the brand has to make a core container that's durable enough to last for years.
Right. If the hinge breaks on the second refill, the whole system fails.
And the environmental math here is tricky. If you buy a heavy, durable, refillable jar, which takes more energy to produce, and you only refill it once.
You've actually done more damage than if you just bought the disposable one to begin with.
Exactly. The break-even point might be 5, 10, maybe 20 refills. If the consumer doesn't stick with it, the whole sustainability claim just falls apart.
That puts a lot of pressure on brand loyalty. But big players are trying this. The Saloons mentions Estee Lauder piloting refills in their luxury lines, trying to prove that refillable can still feel prestige.
And then you have Unilever, which is looking at standardizing components to do this at a massive scale.
That standardization point is so interesting. If every brand used the same size neck for their bottles, imagine how much easier recycling or refilling would be.
It'd be like the USB-C charger, but for lotion.
It would be a game changer. Just reducing the number of unique shapes and sizes, the skiz drastically cuts down on waste.
Okay, so we've talked about materials and design. But how do brands actually know if they're making the right choice? Because the glass versus plastic trade-off, it feels like a game of 4D chess.
It is. You fix one thing, you break another. And that's where the science comes in. We have to talk about LCA's life cycle assessments.
This sounds like the data-heavy part of the deep dive.
It is, but it's crucial. You can't just feel like a package is sustainable. You have to prove it. An LCA measures the environmental impact from cradle to grave.
From the moment the raw materials are mined to the moment it hits the landfill.
Or the recycling plant. And there was a specific term in the source that I found really useful. The functional unit.
Can you unpack that for us?
Yeah, this concept cuts through a lot of marketing fluff. Instead of just weighing the package, you measure the impact based on the volume of product the package delivers.
So it's not just this bottle is heavy, it's this bottle delivers 50 milliliters of serum with X amount of carbon impact.
Exactly. It lets you compare apples to apples. Let's look at that refill pouch again. Maybe a pouch is hard to recycle, but it's incredibly light and efficient to ship.
So good carbon footprint.
A glass jar is recyclable, but it's heavy. The LCA helps you weigh those contradictory factors against the actual service the package provides.
So there is rarely a perfect option.
Almost never. You might find a material with a low carbon footprint, but producing it uses a ton of water. Or it depletes scarce mineral resources. Brands are constantly weighing these factors.
So when a brand says we are 100% sustainable, they're probably oversimplifying.
They're very likely cherry-picking one metric, and that is why data is so important.
Speaking of data, let's talk about the tiny paper booklet. You know, the one rubber-banded to the bottleneck that has ingredients in 40 languages.
Which almost immediately goes into the trash.
Right. The source calls this the problem with paper. But there is a high-tech solution emerging, digital labeling.
This is the future. We're talking about GS1 compliant QR codes and digital product passports.
A passport for your lipstick.
In a way, yeah. Imagine scanning a code on the bottle and instantly seeing everything. Not just marketing, but the hard data.
What kind of data?
What's actually in the plastic, exactly how to recycle it in your specific region, even the certification data.
That's huge because recycling rules change all the time. A printed label is static. A digital label can be updated.
Exactly, real-time updates. And it goes deeper. In an era of rampant greenwashing where brands just slap a green leaf on a bottle, traceability is the antidote.
So this forces brands to show their receipts.
Yes. Suppliers have to provide verified data. If you claim your bottle is 50% PCR, the digital data needs to show where that recycled plastic came from. It's about chain of custody.
And it sounds like this isn't just brands being nice, they are being forced to do this.
That brings us to the regulatory landscape. The days of voluntary sustainability they're ending. Governments, especially in the EU and parts of the US, are implementing something called EPR.
Extended producer responsibility.
Basically, you make it, you pay for it.
I love that concept. It shifts the burden.
It shifts the cost of waste disposal from the taxpayer to the manufacturer. If a brand designs a package that's impossible to recycle, like that pump with the metal spring, they are going to pay higher fees to the government.
That hits them where it hurts. the bottom line. Suddenly, designing for recycling isn't just good ethics, it's good business.
Precisely. And that's why we're seeing this rush for certifications. The source mentions the big three: Cradle to Cradle, FSC for paper, and ISCC+. These aren't just stickers anymore. They are proof you aren't going to get hit with massive fines.
We mentioned Estee Lauder and Unilever earlier, but the source also highlighted L'Oreal in this context.
Yes. L'Oreal is a great example of a massive ship turning. They are intensifying their use of recyclable packaging and, crucially, securing stable supplies of PCR. They know these regulations are coming.
They're getting ahead of it.
They're locking down the high-quality recycled materials now so they can meet future targets. They are future-proofing their supply chain.
So, looking forward, we've covered the current struggles, the dirty plastic, the heavy glass, the fines. What's on the horizon? What's the next big thing?
If we look at the bio-innovation section of the source, things get really, well, almost sci-fi. We're looking at materials that go beyond just recyclable. We're looking at coatings derived from algae.
Algae, like from the ocean.
Yes, using seaweed extracts to create moisture barriers instead of plastic linings. And packaging made from mycelium.
Mushroom roots.
Exactly. I've seen the mushroom packaging. It looks a bit like styrofoam, but it's totally organic.
It's incredible. You can grow it into a mold in a matter of days. And we're also seeing 3D printing entering the space, not for the final product yet, but for rapid prototyping.
How does that help sustainability?
It prevents waste during development. Instead of creating thousands of metal molds and testing thousands of plastic bottles to get a shape right, you print, test, adjust, and print again.
Failing fast with zero waste.
It feels like we're moving away from that old linear take-make-waste model.
The source calls it the shift to a circular economy. The ultimate goal is that waste is just a resource in the wrong place. We're trying to build a system where the molecules, plastic, glass, biological, just keep flowing through the system.
Instead of ending up in a hole in the ground.
Right.
So, to recap this journey, we started at the recycling bin, totally confused about a moisturizer jar. And we learned that the answer isn't just recycle more. It's about monomaterials, simplifying design.
So the machines can actually process it.
It's a shift to refills, but only if we, as consumers, change our behavior. And it's all underpinned by hard data LCAs and digital transparency.
And it's all driven by a regulatory environment that is finally making waste expensive. The economics are finally aligning with the ethics.
It's a lot for you to think about the next time you pick up a shampoo bottle. It's not just a container, it's a data point in this massive global system.
Absolutely. And if I could leave you with one final thought, it's about the changing definition of luxury.
Go on.
For the last century, luxury in packaging meant heavy. It meant complex. Layers of gold foil, weighted bases, excess. It was about dominance over materials.
The heavier it was, the more expensive it felt. It signaled abundance.
Right. But I think we're seeing a shift. In the future, true luxury might be defined by intelligence, by modularity, by the ability of a product to just vanish without a trace when you're done with it.
Wow.
The ultimate luxury might not be what you hold in your hand, but knowing that you haven't left a scar on the planet.
I love that. Luxury is disappearance. That is something to think about. Thank you so much for guiding us through this deep dive.
My pleasure.
And thank you for listening. We will catch you on the next deep dive.